Hello, this is Frank with Frank's Riser Video Audio Service Sole Proprietorship Business. I also have Frank's Beautiful Rocks and Minerals. This is part 2 of the video for kids that are learning electronics or adults that are just beginning to learn electronics. We are wiring together a resistive substitution box. Substitution means you can select the resistance that you desire for circuit analysis and biasing components properly. Now, what do I mean by that? If we take a look at this piece of garbage power supply, we'll notice inside a circuit board. We have capacitors, voltage regulator, coils, metallized film capacitors, fuse. But notice the resistors inside this component. And there are some over here. Here's a diode, and here are 2 resistors. This capacitor is fed by these 2 resistors. The capacitor is rated at a specific amount of power and voltage. If that voltage is exceeded, the capacitor will fail. Therefore, putting 2 resistors in series, or where the electricity flows into the capacitor, will limit that voltage. Sure, it will drop the voltage down a bit, but it will save the capacitor from exploding. That's one application of why we use resistors in circuits. Continuing with the video. To save time, I've soldered most of the resistors except 2 on the board. The other components are larger. I can't solder in larger components. I have to do the smallest first in order to give myself enough room for it to fit. So let's get busy and solder these components in. These are the last 2 remaining resistors. I'll get my trusty ring stand and set it up so that I can slide you in here and have you aim downwards and watch my work. Let's see what it looks like in my camera, and I think that will be satisfactory. Okay. Can you see the board well? Let's drop this camera down a little bit so you can see the board a bit better. And I'll need room to work, so it's as close as we can get. Onward and upward. A word about solder. Solder is used to connect terminals, metal terminals such as the resistors, onto the board. There are different types of solder: lead, tin, silver solder 5%. This is lead-free solder. Make sure you use the right solder, otherwise you can place improper voltages on the pins. Now, what do we have? we have yet to solder in R23 and R24. R23 is 680 kilo ohms, which would be blue, gray, yellow. And here it is. Blue, gray, yellow. This resistor was missing from the kit, so I have to use my own, and it's smaller, unfortunately, so we'll only be able to deal with less wattage or power to dissipate before burning up. Unlike what I am doing, what you want to do is neatly mount the resistor flush on the board. And that is a disgusting job. I did the other as well. Bend the leads over so that the resistor is held in place. Take your soldering iron and solder. What you want to do, you can see it. Full pattern is on the back. A little piece of metal and the resistor lead. Put a little solder on your tip. Hold it in place. Add additional solder. And hold it there for a little bit. Holding it there will prevent an open solder joint or a cold solder joint, at which point it will act as an open circuit and not allow electricity to enter into that resistor. You may burn resistors a little bit doing it this way, but there's no other way of doing it, and that rarely affects their value unless you burn it completely up. But we will double check our work and I'll show you how. At the end, clip the leads. And finally, we put in our 1 mega ohm resistor, which is brown, black, and green, and that's what we have here. These resistors, except my 1/8 watt resistor, are measured at a half a watt, which is okay. I would have preferred higher wattage, but I didn't design the kit. It would have been more expensive, but it would have been able to handle more power. I'm not using precision resistors, which are blue in color and have more color bands on them. They are higher than a tolerance of 5% of gold. That would have been perfect. But I've never seen a precision resistor higher than 1/8 of a watt. Clip the leads. I don't know why. Now we'll solder in the next smallest component, which is the switch. Oh, I know what these holes are for now. Red and black. Okay, I'll show you in a minute. Actually, that's not the largest. Here's the red lead. Notice, stranded copper wire which I twisted and attached an alligator clip to. It goes in the red socket. Bend it over. Solder it in place. Clip the end of the lead. These are great for cutting wire. This is from Revlon that I got at a food market. Let's prepare the black lead. We take our wire trimmers and we trim off the edge. One on one side, one on the other. Twist the stranded wire together for ease of use. Take the black alligator lead and remove the plastic shielding insulation. And here we are. We're going to use a device called Helpy Hands, which is a device that will allow you to hold the wire in place. Can you see that? Yes, you can. You can see that, right? Yeah. Add some solder to your iron. Oh wait. There's a little hole here. Stick it through and bend it over. Now it's held firmly in place. Solder it in there. I just used the wrong solder. Check it. Is it soldered in place? I don't like that. But I can't move it. Yeah, it's a cold solder. That's a cold solder joint, people. Resolder it. Well, make sure we're soldering it correctly by using the right type of solder. On the side. Use plenty. We're only dealing with wire here. Solder is a metal alloy of 60% lead, 10% tin, but this is leadless. It has no lead. It has resin inside of it, which allows smooth solder flow. Now, it's got these little knobs at the end that you bend over. Not like that. No, we'll forget about it. And now we reinsert the insulation. Big, small. Enter it appropriately on the wire. Open the wire with your alligator clip. It's an alligator clip with your fingers and slide it in. And you are done. Let's solder it into the board. black. It says it right on the board. Very convenient. This is a very nice kit. I've built them before. And I have also donated them, built them and donated them to schools. Nothing to clip there. Short enough. Now we put in the button. The next biggest item, switch. And there's no polarity to this switch. Meaning specific direction that you need to solder it in. I'll grab my helpy hands. Hold the board in place. Stop grabbing the wrong solder. Make sure this solder flows smoothly over the connection. Okay. Aim it at this direction.